Let's chat about Chapter 6, Fire Hazards. Now, a fire hazard is a condition that favors fire development or growth. The majority of fire deaths in the United States are not due to burns or directly attributed to the flames. They are due to asphyxiation, either, as we talked about before, simple asphyxiation, where the smoke just takes up the room of the oxygen, or chemical asphyxiation. So if there's a toxic chemical burning, those fumes can be poisonous and cause acute health effects. So there's a couple terms we want to talk about when we're dealing with fires. The first is combustion. Now, we've talked about this a little bit before with the combustion triangle or the fire triangle. You need three things to have a fire. When you have fuel and oxygen and an ignition source, energy is created. That energy is the fire. The combustion point is the temperature at which a fuel can burst into flame. The fire point is the minimum temperature at which the vapors will continue to burn given a source of ignition. So these terms are important if you're dealing with substances and chemicals and storing them and transporting them. The temperature they're kept at, also what they're allowed to be next to. You need to know if something's going to combust if you're running a welding shop. Like, how far away do certain chemicals need to be away from the hot work to have a safe work environment? The next thing we'll talk about are the classes of fires. So if you've ever taken a second to look at a fire extinguisher, most fire extinguishers, just general purpose, are rated for A, B, and C fires. The letters stand for what they're made to put out. So there's different kinds of fires. The Class A fire is a solid material like paper or wood or even plastic. Just your normal run-of-the-mill fire, think of like a campfire. This kind of fire, water can put out just fine, as well as a Class A fire extinguisher. The next class of fires, Class B, are flammable liquids and gases. The next is Class C, or electrical fires. A Class A, B, C fire extinguisher will put out an electrical fire, but it will typically ruin the equipment because of the composition. They do make special Class C fire extinguishers to put out electrical fires, as well as a couple of other methods to put out electrical fires without permanently ruining the electronics or electrical systems. Then last, Class D are combustible metals. So aluminum, magnesium, titanium, things like graphite will burn. These typically burn at extremely high temperatures. For example, graphite burns at such a high temperature, if you spray water on it, it will separate the water molecules with the heat. So instead of the water, dousing the fire, you're actually going to be adding more oxygen to the fire. It splits that H2O, steals that oxygen, and fuels the fire even further. Magnesium will cause fires. It's very dangerous to machine if you don't have very particular procedures and Class D fire extinguisher handy. A normal fire extinguisher will either do nothing or be extremely dangerous on a metal fire. The next two topics, we'll talk about fire detection and fire suppression. They're both very important. When fires start, there needs to be a way to know that they're happening. So if you have a big factory, if a fire is allowed to burn for more than a few seconds, it can rapidly spread and result in a total loss and the loss of human life as well. So the fire detection is extremely important in industry. You have to know that there's a fire before you can put it out. Now, most large plants will have their own firefighting service, right? You can't just call the fire department If you have a fire in a chemical refinery, they have their own team that'll get there first and start to deal with the fire before the fire department shows up. So the fire detection devices, we have thermal expansion detectors, photoelectric fire detectors, ionization or radiation sensors, and ultraviolet or infrared detectors. I won't go through the details of each one. Just know there's different kinds out there. Some of them detect the smoke, some of them detect just the heat. But it's important that if you're doing maintenance on them, that they do work. They have to be tested periodically. It should be in the facility's maintenance plan. There's a few techniques for putting out fires, so fire suppression. The first is isolation, which separates the fuel from the oxidizer. So there's inert gas systems that can flood an entire room with inert gas. So they're often called the halon systems. They get rid of all the oxygen, and then the fire will go out. The downside to these systems is that if somebody's in that room, say a wastebasket caught on fire, somebody's just fine, and the halon system comes on, they won't be able to breathe. Foam is also used. These are used on aircraft carriers. They have this thick foam that will put out aviation fuel fires very quickly. The downside to the foam is it's typically very corrosive, so they don't use it unless they really have to. The next are water is good for Class A fire. So just like you put out a campfire with water, any solid materials, water puts out just fine. The next are gas extinguishers. These are designed for Class C fires. They're made to get rid of the oxygen. So CO2, nitrogen, and halon will all flood the environment and get rid of that oxygen so the fire will go out. These are made to protect the electrical systems from damage. The last are the solid fire suppressants. So these are used for Class B fires, things like oil and grease. So sodium or potassium bicarbonate. If you have a deep fryer, you never want to throw water on it if there's a fire. It will explode. So even regular old white flour will aid in putting out a grease fire. So that's it for Chapter 6.